When a massive natural disaster hits, we all see the headlines. But behind those stories, there's a financial shockwave that can be just as devastating. So, how on earth do you even begin to calculate the risk of something that might only happen once a century? Well, today we're going to dive into the incredible science of trying to predict the unpredictable. First things first, let's set the stage. The financial fallout from these disasters isn't just big, it's growing at a really alarming rate. It feels like we're seeing these record-breaking losses become, well, the new normal. Just take a look at the California wildfires back in 2017. The damage from those fires alone, a staggering $17 billion. But this wasn't just about the money. This was a real turning point. It was the moment when insurance executives, not just the climate scientists, started to explicitly say, hey, these massive events are linked to climate change. And 2017 wasn't some random fluke. If you look back at the pattern, you can see it building. In 2010, you had the Haiti earthquake, a terrible loss of life, but the economic damage wasn't as huge. Then, just 1 year later, 2011, completely shattered all the records. We're talking $330 billion in losses, mostly from earthquakes in New Zealand and Japan. And then boom, 2017 hits with Hurricane Harvey. The trend is crystal clear, and it's pointing straight up. That 2011 Japan earthquake is a perfect and, frankly, terrifying example of why these things are so hard to model. See, it wasn't just the earthquake itself. The quake triggered a massive tsunami. That tsunami then slammed into the Fukushima nuclear reactor, causing it to explode. It's this cascade of disasters, this chain reaction that no one saw coming, that makes the outcome so much worse than anyone could have possibly predicted. So what does this all look like when you put it on a chart? Okay, you're seeing two things here. The taller bars, that's the total economic cost of disasters. The shorter bars show how much of that loss was actually covered by insurance. Now, they're both going up, but the really important thing to see is that huge and growing space between them. That's what experts call the resilience gap, and it represents a massive financial vulnerability for, well, all of us. So, okay, that brings up a really important question. If the risk is this huge, why is it so incredibly difficult to predict? Let's get into the nitty-gritty of what makes modeling these rare, super high-impact events so uniquely challenging. Think about something pretty straightforward, like car insurance. To figure out your premium, insurers use what are called actuarial models. They have tons and tons of historical data on common stuff like car thefts. It's all based on past events. But what about a mega earthquake? Something that might happen once every few hundred years. You just don't have that historical data. That's where catastrophe models come in. They can't rely on the past. They have to use science to simulate the future. So you're basically facing a perfect storm of problems. The events themselves are, by definition, incredibly rare. They can cause these totally unexpected ripple effects, like when the levees broke during Hurricane Katrina. And with climate change, the past is becoming a less and less reliable guide for what's coming next. And if that wasn't enough, we now have entirely new risks to worry about, like a major cyber catastrophe, where we have literally zero historical data to learn from. Okay, so given all those challenges, how do the modelers actually build these things? For a long time, the whole process has been a bit of a black box. Let's take a peek inside, shall we? It's basically a 4-step recipe. First, scientists use supercomputers to simulate literally millions of years' worth of possible events, every hurricane or earthquake you can imagine. Then, for each of those events, they map out the specific hazards, things like wind speed or how deep the floodwaters get. Third, they layer on what's called exposure data, which is just a fancy way of saying a detailed list of all the buildings in the area. And finally, they figure out the vulnerability, predicting how a specific building will hold up against a specific hazard. But after all that science, all that engineering, there's one more step. And this is where things get a little fuzzy. It's a kind of black box calibration stage where modelers apply what they call expert judgment to tweak the final numbers. They might adjust the output to make it feel more credible, and this lack of transparency has always been a really big problem for everyone who relies on these models. So how do you fix a black box problem? Well, you open it up. A new approach has emerged, built around an open source framework that's designed to bring transparency and teamwork to this whole field. This is a huge shift. On one hand, you had the old way, these clunky, closed-off systems built on aging tech that were super inflexible. One expert fantastically described them as being held together with gorilla tape.
But the new way, led by a platform called Oasis, is built on a modern open source foundation. It's all about flexibility, transparency, and getting more people to collaborate.
So what exactly is Oasis? You gotta think of it as two things. It's an open source software platform, yes, but it's also a community. It's a group of scientists, developers, and insurance experts all working together with one shared goal: making these vital risk models more open, more accessible, and ultimately, a heck of a lot more accurate. And here's where it gets really cool. This new open platform is the perfect launchpad for plugging in the latest, most powerful technology out there. So let's see how artificial intelligence is now being used to make these models even better. All right, case study number 1. This one is all about one of the most important pieces of the puzzle, that exposure data we talked about. Getting the details right about every single property at risk is absolutely crucial. And just how crucial is it? Well, get this. Even tiny little mistakes in that data can lead to massive errors in the final risk estimate. We're talking errors of 20 to 100%. Something as simple as knowing if a building's front door is at ground level or 3 feet up can completely change its flood risk. This is where AI is a complete game changer. Researchers are now training neural networks, a type of AI that's kind of modeled on the human brain, to automatically look at pictures of buildings. The AI can see key features, like the height of a door, if the ground is sloped, or how many windows there are. It automates the whole process of checking and fixing the data, which drastically slashes that uncertainty we were just talking about. Okay, for our second case study, we're zooming out. Instead of looking at individual buildings, this one uses AI to find brand new patterns in our climate system, all to create better long-range hurricane forecasts. So the old way of doing this, scientists would pick a few variables they already knew were important, like certain patterns in ocean temperature. But the AI method, it's totally different. It treats the entire global map of ocean temperatures like one giant picture, and just tells the algorithm, go find any pattern in here that helps predict hurricanes, even patterns humans have never noticed before. And get this? It works. This approach actually took first place in a major forecasting competition last year. That's a huge deal. So, we've talked about compounding risks, black boxes, open source, and AI. But let's take a step back for a second. What's the big picture here? Why does making these complicated models better really matter to you and me? Because at the end of the day, this isn't just about helping insurance companies manage their bottom line. Better models are absolutely essential tools for building a more resilient society for everyone. They help us understand where to invest, how to build stronger homes and infrastructure, and ultimately, how to protect our communities before a disaster strikes. And that really leaves us with the big question we all need to think about. In a world where risks are changing all the time, the biggest challenge we face is this: how do we shift from just predicting losses to proactively using these incredible tools to build a genuinely safer future for all of us?